Good evening. My name is Eric Rame, and I'm with USC Upstate ETM 499 Senior Seminar Class. This is a box report on acceptable risk, report 4.12. The key points summarized are engineering design is trial and error. Loads are usually estimated, mathematical principles and well-tested equations are used to attest the effects of the loads, and then the risks are determined. Are they going to be acceptable? Are you willing to accept the risk? Or do you need to do a little bit of redesign to get the risk lower to a level that you will accept? They had an example of the City Court building. It required a unique design because of where it was located in the city. So a well-known engineer took it on. He estimated the loads off of his design. He did his math. He did use the equations that are normally used to test the effects of all the loads. His risks were determined, and he determined that everything was acceptable. Well, after the building was complete, a particular load effect was found actually by an engineering student that the designer did not take into account. It was basically the designer had used wind load, but he used it on the sides of the building, not on the corners. Once the designer realized the situation, he looked into it. At first, he was a little bit skeptical, but he chose to look into it, and come to find out, when he looked into it and recalculated everything, there was some risk there that he was not willing to accept. So he contacted the owners of the building. He made some design changes. He implemented the changes, and that's what he decided to do. So from this, you see what the designer responsibilities are. He could have done nothing. He could have just kept this information to himself. Maybe something wouldn't have happened for maybe 50 or 75 years. He'd probably be passed away by then. But that's not what he chose to do. He was worried about his stature and respecting the engineering community. So he fixed the situation, and by doing so, he gained considerable stature within the professional and public eye. Nowadays, he goes around lecturing to colleges and universities about what could have been his greatest disaster in his career, but instead it turned out to be one of his greatest engineering triumphs. There is ways to decrease risk in engineering. There was an example in the report about hose connections on a fuel type. They have jet fuel and propeller fuel. Well, somehow, one time, or I'm sure it happened more than once, somebody put propeller fuel in a jet or jet fuel into a propeller plane, and bad things happened, I'm sure. Either just tore the equipment up or had a crash in flight, if they even made it off the ground. So you can change engineering to benefit society by, they made a hose connection for the jet that would only fit into the jet, and a hose connecting for the propeller planes that only fit into a propeller, so that they could never be interchanged. And one thing that was mentioned was that is one of the greatest satisfying aspects of engineering, is that you can reduce risks by engineering. It will help society in the long run. Chapter application, we're back to Chris. He has this dilemma with passing this design by a former employee as acceptable when he's determined that there's possible concerns with the design. He discussed it with his management team, and they determined it should be fixed, but they're not really explaining to the customer fully, the design situation. I will say one thing, at least the management team decided to fix it, but I'm a little curious about why they're not sharing it with the customer as much as they should. I guess we'll find out more as we read the book. Some real world application that I picked out was Japan nuclear power plant. I was actually supposed to fly into Japan that exact same day that all that hit, but they ended up canceling our trip over there because of a death in the family to the vice president I work for. So, I missed the whole situation. We were flying into Tokyo that exact same day. So that's kind of a God thing, I think, but things happen. But one thing that came to my mind was, why in the world did they build this nuclear power plant, near an earthquake fault zone? Why did they build it along the coast where tsunamis are prevalent? It just amazed me that once I did a little bit of research, why all these decisions were made. Then it brings up the fact of, should the designers of the actual nuclear reactors be held responsible for what happened? GE, Toshiba, Hitachi, Mitsubishi, they all, Siemens, they all build nuclear reactors. Should they be held responsible for the way people use them? I read an article when I was doing this report where a group of about 1,400 people got together in Japan, and they are actually suing the nuclear reactor manufacturers for the situation that had there. I don't know what the result's going to be, but I guess time will tell. A couple additional sources that I picked was building of nuclear power plants. It's just an article about what is the acceptable risk of planning a nuclear power plant. We got one in Oconee. They're considering building one over in Cherokee County that they abandoned a few years, or about 20 or 30 years ago. It's just, it's whatever you think is acceptable is what's going to happen. And then this is a little bit far-fetched. I was looking through some information and ran across the Greenpeace website. They kind of in my opinion, kind of takes things to the extreme, but you can look through a lot of their articles and see what their stance is on everything. It's a little bit skewed to one side, but you can make your own decision about that. Well, I'd like to thank you for listening to the presentation and hope you have a good evening. Thanks.